So in this video, which is going to have three sections, a section about understanding, a section with some numerical examples, and a part with some algebraic examples, I'm going to ask various questions, and what I suggest you do after I've asked the questions is pause, and then with pencil and paper work out what you think the answers are, and then you can restart the video and see if you have them correctly. So the first questions are about understanding, and they are: what does x to the p mean? What does x to the minus p mean? What does x to the 1 over p mean? What does x to the minus 1 over p mean? And what does x to the q over p mean? So at this stage you can just decide what your answers are, pause the video, and then start again. Okay, welcome back. So the first question, what does x to the p mean? It means x multiplied by itself, so x multiplied by x, multiplied by x, multiplied by x, p times. The next question, x to the minus p, means 1 divided by x to the p. So in other words, it means 1 divided by xp times. The third question, what does x to the 1 over p means? It means the pth root of x. In other words, it means a quantity or a number which, when you multiply it by itself, p times gives you x. Similarly, x to the minus 1 over p, just as here, means 1 over x to the 1 over p. That's all the minus sign means. So this is 1 divided by the pth root 1 over p, x to the 1 over p, 1 divided by the pth root of x. And finally, x to the q over p. Well, using one of our rules for powers, we can write this as x to the 1 over p all to the q. In other words, it means the pth root of x multiplied by itself q times, or equivalently we could write this as x to the q all to the 1 over p, and that shows that it can also mean x multiplied by itself q times is a quantity, and it is the pth root of that quantity. So it's the pth root of x to the q. So that is what these ideas mean. And now in the next section, which I'm going to do on the next slide, we're going to look at some numerical examples. So the first set of numerical examples are to work out what are 2 to the power of 3, 3 to the power of minus 2, 8 to the 1/3, 2 to the minus 1/2, and 125 to the 2/3. So again, if you could pause the video, calculate them, and then come back. Okay, welcome back. So if we look at the first example, 2 to the power of 3, this means 2 multiplied by itself 3 times, it is 2 cubed, and that is 8. The next example is 3 to the power of minus 2, and that means 1 divided by 3 squared, because that is all that the minus sign in a power means. It means you are dividing by that power, so that means that we have 1 divided by 9, a ninth. 8 to the 1/3 means the cubic root of 8, and the cubic root of 8 is, of course, 2. It's easy to verify that. You just check that 2 cubed gives you 8, which we have indeed already seen. The next example is what is 2 to the minus a half, and that means what is 1 divided by 2 to the half. Now 2 to the half is the square root of 2, so this is 1 divided by the square root of 2. Finally, we have here 125 to the 2/3, and we could try to work that out in different ways. One way would be to say that we take 125 and that we square it, and then we take the cube root of it. And that would be rather complicated to work out. The other way is to recognize that 125 to the 2/3 can also be written as the cube root of 125 squared. These two ways of writing this number are equivalent, and the cube root of 125 is 5. 5 cubed is 125, and 5 squared is 25. So with that, we've completed this first set of numerical examples. And on the next slide, we're going to look at a few additional numerical examples. So what we now want to do is to look at some numerical examples which rely to solve them on using these laws for powers here. So 10 to the 6 times 10 to the 7 is one question. What is 10 to the minus 34 times 10 to the 15? What is 10 to the minus 31 over 10 to the 7? And what is 10 to the 6 over 10 to the minus 3? So again, pause the video, work out the answers, and then start again. Okay, welcome back. So the first example, 10 to the 6 times 10 to the 7, is 10 to the 6 plus 7, so it is 10 to the 13. The second example is 10 to the minus 34 times 10 to the 15, so we add the 15 here, and minus 34 plus 15 is minus 19, 10 to the minus 19. The third example, we're now dividing by 10 to the 7, so if we're dividing we have to subtract the power, just as here in this rule. So this is 10 to the minus 31, that's what we have in the numerator, and then we subtract the power in the denominator, so it is minus 7. So this is 10 to the minus 38. And the final example here is 10 to the 6 divided by 10 to the minus 3. So this is 10 to the 6 minus brackets minus 3. That is 10 to the 6 plus 3. So that is 10 to the 9. So all of these examples are worked out using these two rules. So we'll now go on to another slide with some additional examples. So in this final set of numerical examples, we have the square root of 2 cubed times 2 to the 5th divided by 2 to the 4th and 2 to the minus 10. And as well as that, we have an example of how the rules for powers are often used in scientific calculations. And here we have 9 times 10 to the minus 31 multiplied by the square of 3 times 10 to the 8. So again, if you pause the video, you can work out the answers and then start again. So let's look first of all at this example. So what we have here is the square root of, and let's simplify the numerator first, 2 cubed times 2 to the 5th is 2 to the power of 8. On the bottom, 2 to the 4th times 2 to the minus 10 is 2 to the 4 minus 10. 4 minus 10 is minus 6, so we have 2 to the minus 6. We now have 2 to the 8 divided by 2 to the minus 6 inside the square root, so this is the square root of 2 to the 8 minus 6, so that is 2 to the 8 plus 6, and 8 plus 6 is 14. The square root means the power of whatever is in the square root to the half, so this is 2 to the 14 divided by 2. 14 over 2 is 7, and 2 to the power of 7 you can verify just by multiplying it yourself. Out 7 times is 128. So that was our first example where we've used many of the rules for powers to calculate the answer. The second example, as I said, is the sort of thing that often happens in scientific calculations. So what we have here is we have 9 times 10 to the minus 31. We then have a quantity of two numbers multiplied together squared, so the square of that is the square of each of the factors. So we have times 3 squared times 10 to the 8 squared. 10 to the 8 squared means 10 to the 8 times 2, which is of course 10 to the 16. What I now want to do is I want to put the numbers here together, and I want to put the powers of 10 separately together. So I'm just going to change the ordering in which I multiply them, which is something I can always do. So I have here 9 from here, and I also have 3 squared, but 3 squared is of course also 9. So I have 9 times 9. I then have times 10 to the minus 31 times 10 to the 16. So this means that I have 81 from 9 times 9 times 10 to the minus 31 plus 16, and minus 31 plus 16 is 10 to the minus 15. Now, this is not scientific notation. I really want to leave this, my answer here, as a number with one non-zero digit in front of the decimal point. So to write this in scientific notation, a nicer way of writing it is to write this as 8.1, which means that I have divided this number by 10. If I've divided this number by 10, I have to multiply this one by 10, or I would have changed the overall number that I have here. So I can write this as 8.1 times 10 to the minus 15 times 10 is 10 to the minus 14. And that is the final result. And as I indicated, this sort of procedure here of putting all the powers of 10 together is a very typical thing that is done in scientific calculations, where we're often faced with very large and very small numbers such as 10 to the minus 31, which is very tiny, and 10 to the 8, which means 100 million, and is clearly a large number. So this sort of thing is very, very typically done in scientific calculations. So, to conclude the video, we're now going to look at some algebraic examples. So, to conclude the video, we want to look at the following examples: x to the p multiplied by x to the 3p, w to the q divided by w to the minus q, xy all to the t multiplied by y to the t, s squared to the x over 2, and a to the t times a to the 2t divided by a to the t over 2, and also divided by a to the minus 2t. So again, if you could pause the video, work out the answers, and then we will look at them. So, welcome back. The first example, x to the p multiplied by x to the 3p, is x to the p plus 3p, so it is x to the 4p. The second example is w to the q, and then because we are dividing we have to subtract the power. So this is w to the minus q, so brackets minus q. So this is w to the q plus q, so this is w to the power of 2q. The next example, x times y all to the t times y to the t. Well, we can look at the brackets and expand it, recognizing again we have a product of two factors, so this means x to the t multiplied by y to the t, x to the t multiplied by y to the t, and then we also have this factor of y to the t, and then we can recognize we have x to the t here multiplied by y to the t plus t, so this is y to the 2t. The next example is s to the 2x over 2. We multiply the 2 and the x over 2 together. The 2's are going to cancel here, so we are left with s to the power of x. And in our final example, if we sort the numerator out first, we have a to the t multiplied by a to the 2t. We add the powers here, so this is a to the 3t. And on the bottom, we again add the powers here, so we have t over 2, but this is negative, so it's t over 2 minus 2t, so that is a to the minus 3t over 2. And now we have a to the 3t, and we subtract the power on the bottom. This was already negative, so when we subtract it, it becomes positive. So it's 3t plus 3t over 2. And this, when we recognize that 3t is 6t over 2, 6t over 2 plus 3t over 2 gives us a to the power of 9t over 2. And with that example, we're going to conclude this video of questions on the use of powers.